This Talend Data Mapper tutorial covers the basics of structure inheritance. It's the first part of the structure inheritance tutorials. Now we're going to show some of the basic things about structure inheritance, including the interaction between structures and maps when structures change. So the first thing we're going to do is we're going to work in this project I call examples 1, which I made by copying the examples project. And in the simple directory, there's a directory called PO standard. And this is a set of structures that was built up using inheritance to describe a purchase order file. So we'll look at the finished product, which is this PO file structure. And that describes an XML document which has a root of POs, and then it has a number of purchase orders within it. And this is built using structure inheritance. So if you in the element property, if you see inheritance specified, it shows a link to the inherited structure. You can also change the properties here, and if you want to change the inheritance or set the inheritance in the inheritance from, you just use this little button here, and it will allow you to set the inheritance to another structure or remove the inheritance. It also treats the inherited root here. So what the inherited root means is, how do you deal with the root of the structure you're inheriting from? Because this PO structure that we're inheriting from, if we go back here and look at this structure, it has properties, and then the element that the element at the point of inheritance has properties. So the inherited root deals with how do you handle those properties. So one option, and this is the option we've selected here, is to use only the children of the inherited structure. We don't, all the properties that for the element at the point of inheritance are those in the inheriting structure, in the PO file structure in this case. The other thing we can do is the opposite. If we say use everything, that would take all of the properties, including the name, from the inheriting structure. And then there are various options here which are specific to certain use cases. So for example, in XML schema, you normally want everything except the names and the number of times it occurs. And for EDI, there's other options here. So that's the point of the inherited root. So here we see the PO file is composed of a PO structure. Notice the icons have the black arrow. So what that means is that these are inherited elements. And if we drill down into this, we can look at the PO structure, and the PO structure also uses inheritance. So we look at address, for example. So address occurs here, and it inherits from this address structure. And address also occurs in delivery as the deliver to address, so it inherits there. So this is a classic reason of why you'd use inheritance, which is to reuse things. When you import XSD or EDI or databases or Java, what it will do is it will create structures that are based on the components of whatever you're importing. So for Java, it will create a structure for each class. For XSD, it'll create a structure for each type and each element and each attribute group and so forth. For EDI, it'll create structures for segments and elements and composites. And then it will build up the larger structures based using inheritance in all cases. So inheritance is used in the same manner no matter what type of data you're working with to get reuse. But it also can be used for customization purposes as well. So let's build up this PO file structure a little bit just to show you a way that you can set up inheritance. So we'll just create a brand new structure. Where we manually enter elements. So it has the POs element, and then we're going to create an element for each purchase order. So I've created the POs element because that's the outer element that is that the document expects. Now let's associate a sample document with this. To do that, you can just hit the Show Document button, and then if there's no sample document, it will ask you where to get one. Well, we'll get an existing one from the workspace here. Okay, so it's showing this document, and it will highlight everything because even though it doesn't know the structure of it, it knows that there's a POs element which matches the POs element here. So everything is in order. Now, what we can do is make this PO element inherit from our PO structure. So you can set it over here. From setting the inheritance from. Notice that it's blank right now. Or an easier way to do it is you can simply drag and drop. So we can drag from the Project Explorer, we can drag the PO structure right on top of the PO element here, and then it will set inheritance, and it will set it by default to use only children, which you can change if you want. So we've now just created the same structure as the PO file that comes with the samples that uses inheritance. So now let's look at customization a little bit and see how that works. So the first thing to show this will be to create a map. So let's create a new map, and all right, and then we'll use our PO file structure in the map, and we'll just make this a trivial map that maps the same thing. And so this is just a simple pass-through map. It really doesn't do anything. If we drag the input to the output, this will automatically map everything by name. So if we run the map, we can see that it produces the output, which is identical to the input. Not very interesting, but nevertheless useful for testing and demonstrations. So now what we can do is see how customization works. So say in this PO file, we're inheriting, the typical use case is for customization is there's some standard somewhere that may be defined by EI or XSD or whatever, and that then the user of that standard needs to customize it, or they also need to do potentially a version migration. So whenever you're working with a map, you'll generally never work directly with the structures that define the standard. Instead, you'll create a custom structure, which then you work with. So in this case, let's assume that the PO file is the standard. So let's create a custom structure based on that. All right, now we're going to create a custom structure for the PO file. So we'll use our new structure wizard. We're going to create a structure that's a customization, and we're going to customize PO file. Call it custom PO file. So now this structure looks identical to the PO file structure, and we can associate the sample document with it. You really should actually use the existing sample documents, but that's something that can be added to the product at some point. We'll select the same sample document that was used for the PO file structure. So now we're using that document. Now in our custom structure, let's say that we want to restrict the company name field to 10 characters instead of being unlimited, so we'll change it to 10. And then we'll show how this works in the context of a map. So we'll create a map that uses this custom structure, standard map. And we'll
have this map just be a pass-through map. So it just maps to itself, which is often useful for testing the mapper. One way I dragged the file from the input to the output, and there's another way you can select the structure, which is you right click and select output structure, and then you have you can use this resource finding dialog to find it that way. So depending on whatever way you want to do it. So, and we'll just map the input to the output. When you drag an element to the input, the output, it will match up anything by name. So we'll run the map, and we see that it simply produces the input. Now, what we want to do is turn on validation of the structure. So that's not by default set in a map. So if we want to work with the map, we'll look at the map properties here from the Project Explorer. Look at the mapping properties associated with the map. And here there's all kinds of different properties that you can change the input or output structure and select the representations. Here we're going to click on Validate Against Structure. So what that does is that will validate the input against everything that's known about the structure definition, the number of occurs, the size, and all of that. So now when we run the map, we'll see a validation error because we set the size to 10. So the map still produces the same output, but we see that in the two cases of the company name, we see that the element exceeds the maximum size. And notice how it reports the value that it saw, gives you a link to the map element, and tells you the location of it in the file. So this was an example of using the custom structure to have specific rules beyond the standard and then using those in a map. Now we're going to simulate a change to the standard and see what happens with the map. So say there is an address created. Say that there's something that happens with the address that we want to have a region, say. So we can add a region element. And also that they decide that the street 2 element is no longer necessary in the address, so we can delete that. So we're changing just the address structure, which is inherited from at several levels. So now, if we go look at the map again, what will happen is we'll get some additional warnings indicating that some elements no longer appear in the structure, and we click on the element and we see that the street 2 element has been removed from the structure. Now it's left in the map because there might be some mapping instructions. And also we see that the region element is there, and it's indicated with a little star indicating it's new. So what it will do is it will point out anything that's been removed and anything that's been added in the map, but it won't delete anything from the map. So it lets you actually preserve the mapping instructions if you want, and then you can manually remove these items in the map and manually remove the new element indication. So it keeps these warnings until you address them. Now, one of the things you can do is actually map it. So if we went to the address here and we mapped the region to the region, then notice that it removes the indication that it's a new element because now you've mapped it. So this is the basic process for how the structure is reconciled with the map. That again, it preserves the mapping information. Now, once you've satisfied that you've dealt with all the items in the map, you can delete them individually. So we can delete this invalid map element here. That's what it's called when it's got it's invalid because there's no structural element behind it. Or you could at any level delete all the invalid map elements. So you can say delete the invalid map elements, and you can also say remove the new element indications. And we can do that on both sides of the map. So then Now if we run the map, it will run, and we still get our two errors associated with uh, um, the company being the wrong side. And we're also getting a warning because it saw an element, street 2, which was present in the data, but it wasn't in the structure, which is to be expected given this data. So we've shown just some basics about structure inheritance, how it works, how you inherit, how you what the significance of the root element is in inheritance, how you can customize structures using inheritance, and a little bit about how the map and the structures are reconciled when you open a map. Another thing I want to point out here is you'll notice that there's automatic dependency management. So if I change some structure and then I save it, after I save it, whenever I open any structure or map that depends on it, it will automatically validate that against against those changes. So you'll notice I open this map. Now this map depends on this custom structure here, which depends on this PO file structure, which depends on this address structure. So it went through a chain of 3 different structures and revalidated all that to make sure that the address information ended up being correct in a map. And one of the things you can do, so that happens always automatically. When you save something, it will make sure it's validated. Even if it doesn't happen to be open in an editor, next time you look at it, it will revalidate it. And the other thing you can do is on any metadata object, you can see what the object is used by. So this map shouldn't be used by anything because it's a map. And we can see what it uses. So we can see this map uses the custom PO file structure. It's not transitive, it just says what it directly uses. And then if we go to the custom PO file structure, we can see, for example, it's used by this map, and then it uses a PO file. And the other thing we can do is at the project level, we can show objects needing validation. So there are a number of objects here because of various things that have changed that require validation because things on which they've depended changed. And then what you do is once you look at the object that requires validation. So here, because we changed this address structure and it's used by several other structures in the map and maps, there were a number of objects that needed validation. So we've opened up this map which requires validation because the street 2 is no longer there and the region has been added. And if I don't do anything with this, it will still appear in the list of objects needing validation because it still has the warnings about the missing element and the new elements. Only when I clear out the warnings, either individually or as a group. So now I'm going to clear out the warnings here, and normally I would I may map items or whatever. So now if I show objects needing validation, that map no longer appears. So basically you can this is the way to get impact analysis. You can tell something what something is used by, what something uses, and you can also at any time find out anything that requires validation that you have to manually look at and make sure is correct and clear any warnings. And then once you do that, the notification will be removed. So that completes the tutorial on basic structure inheritance and the basic relationship between structures and maps.